exploring the universal laws of physics as a common ground, a Technosignature research perspective.
Welcome to the Universal Principles podcast. Today we're diving into the fascinating idea that the laws of physics act as a universal common denominator. We'll be looking at how this impacts our search for extraterrestrial intelligence. I'm excited to explore how a principle so fundamental can shape something as complex as the search for alien life.
Thanks for having me. In the field of technosignature research, we're essentially looking for evidence of alien technology. What's fascinating is, despite potential differences in alien biology, cultures, or tech, these civilizations must operate within the same fundamental laws of physics as us. These laws provide a basis for predicting and identifying potentially detectable technosignatures. So, physics becomes our Rosetta Stone.
That's a great hook, so how can we use universal physics laws? Could you walk us through how that works?
Sure, the higher concept here is that physical laws impose constraints on all systems. These constraints create predictable patterns and commonalities, even across vastly different domains. Identifying and leveraging these constraints can improve the efficiency of any search or discovery process, like looking for aliens.
Okay, that makes sense, so give us some concrete examples. How do these laws guide our search?
Well, a major example is the assumption that any advanced civilization will likely use electromagnetic radiation for communication. Why? Because of its speed and relative ease of manipulation. That's physics. So, we search for narrowband radio signals and pulsed lasers, knowing those are efficient ways to transmit information across vast distances, regardless of who's sending them.
So we're betting on aliens being bound by the same cosmic speed limits as us. Got it. What's another one?
Another is the search for Dyson spheres. This idea suggests that any civilization needing vast amounts of energy will eventually try to harness the energy output of its star. This would lead to observable changes in the star's spectral signature. Again, thermodynamics, the laws of energy, dictate that capturing stellar energy is a logical, if extreme, step for a super-advanced society. Basically, they would need to eat the sun to keep growing.
Wow, that's ambitious. So whether it's radio waves or gigantic sun-eating structures, we're using physics to narrow down the possibilities. Are there similar constraints that have been applied in different fields?
Absolutely. Consider the paradigm of convergent engineering in cosmic archaeology. It suggests that certain engineering solutions will be independently arrived at by different cultures given similar environmental constraints and technological capabilities. This is similar to how different cultures independently invented the wheel or the arch, driven by the physics of structural stability and transport.
That's fascinating. Now, for our listeners who might want to apply this principle in their own lives, what are some practical tips you can share?
Okay, 3 quick tips. First, always start by identifying the fundamental physical constraints of your problem. What are the limitations you absolutely cannot break? Second, think about optimal solutions within those constraints. Where do physics push you towards? And third, look for convergent solutions in nature or other fields. How have similar problems been solved before, guided by the same physical principles? For instance, in aerospace, engineers design aircraft based on aerodynamics and fluid dynamics.
Excellent advice. So understand the rules of the game, figure out the best moves within those rules, and learn from others. Thanks for shedding light on how universal laws of physics can guide our search for alien life and solutions right here on Earth.
My pleasure. It's all about recognizing the underlying patterns in the universe.
And that's all the time we have for today on Universal Principles. Tune in next time for more explorations into the fundamental building blocks of everything. Who knows what cosmic secrets we'll uncover next? Until then, keep looking up.